I am Monica. My seminar topic is Arithmetic Mean from Statistics. Arithmetic mean. The arithmetic mean of a data is the most commonly used of all averages and is found by adding together all the values and dividing by the number of items. For example, a cricketer played 8 T20 matches and scored the following scores: 25, 32, 36, 38, 45, 41, 35, and 36. Then the mean of his scores, that is, the arithmetic average of the scores, is obtained by x bar equal to summation x by n equal to 25 plus 32 plus 36 plus 38 plus 45 plus 41 plus 35 plus 36 divided by 8 equal to 288 by 8, which is equal to 36. In general, if we have n number of observations x1, x2, x3, etc. up to xn, then their arithmetic mean denoted by x bar is given by x bar equal to sum of all the observations by number of observations. X bar equal to 1 by n summation of xi, where I varies from 1 to n. We express this as a formula x bar equal to summation x by n. Arithmetic mean ungrouped frequency distribution. Consider the following list of heights in centimeter of 12 students who are going to take part in an event in the school sports. They are 140, 142, 150, 150, 140, 148, 140, 147, 145, 140, 147 and 145. How will you find the mean height? There are several options. First one, you can add all the items and divide by the number of items. Second method is you can use assumed mean method. Assume 141 as the assumed mean. Hence, we can find out the mean as 144.5. Third is to deal with an ungrouped frequency distribution. You find that 140 has occurred 4 times, implying 4 is the frequency of 140. 142 has occurred only once, indicating that 1 is the frequency of 142 and so on. Hence, we can get the following frequency distribution. You find that there are 4 140s, their total will be 140 into 4, 560. There is only one 142, so the total in this case is 142 into 1 equal to 142. There are two 150s, their total will be 150 into 2, which is equal to 300. These details can be neatly tabulated as follows. Hence, the mean equal to sum of all fx divided by number of items, that is 1734 divided by 12, which is equal to 144.5 centimeter. This arithmetic mean group frequency distribution. When data are grouped in class intervals and presented in the form of a frequency table, we get a frequency distribution like this one. So the above table shows the number of customers in the various age groups. For example, there are 120 customers in the age group 20 to 30, but does not say anything about the age of any individual. When we form a group frequency table, the identity of the individual observations is lost. Hence, we need a value that represents the particular class interval. Such a value is called mid-value, midpoint or class mark. The midpoint or class mark can be found using the formula given below. Mid-value equal to UCL plus LCL divided by 2, where UCL equal to upper class limit and LCL equal to lower class limit. In group frequency distribution, arithmetic mean may be computed by applying any one of the following methods. So there are 3 methods. The one is direct method and assumed mean method, and the final one is step deviation method. So let's see about direct method. When direct method is used, the formula for finding the arithmetic mean is x bar equal to summation fx divided by summation f. where x is the midpoint of the class interval and f is the corresponding frequency. Let's see the steps. First one, obtain the midpoint of each class and denote it by x. Second one is multiply those midpoints by the respective frequency of each class and obtain the sum of fx. And the final one is divide summation fx by summation f to obtain mean. Problem 1 is the following data gives the number of residents in an area based on their age. Find the average age of the residents. So here in the table we can see the age and the number of residents. Now let's see the solution. So here I have tabulated the age, number of residents and mid value and fx. So fx is nothing but multiplying the number of residents and mid value. So by that we can find out fx. So mean equal to x bar equal to summation fx divided by summation f, which is equal to 860 by 30 equal to 28.67. Hence the average age equal to 28.67. Now let's see the second method, that is assume mean method. We have seen how to find the arithmetic mean of a group data quickly using the direct method formula. However, if the observations are large, finding the products of the observations and their corresponding frequencies and then adding them is not only difficult and time consuming but also the chances of errors. In such cases, we can use the assume mean method to find the arithmetic mean of group data. So let's see the steps. First one is assume any value of the observations as mean A. Preferably choose the middle value. Calculate the deviations d equal to x minus a for each class. Multiply each of the corresponding frequency f with d and obtain summation fd. Apply the formula x bar equal to a plus summation fd divided by summation of f. So now let's see one problem. Find the mean for the following frequency table. So in this table we can see the class interval as well as frequency. Now let's find out the solution. Let assume mean A equal to 170. So in this table I have mentioned the class interval, frequency and the mid value and d, which is x minus a and fd. So by this table we can use formula and find out the solution. Mean x bar equal to a plus summation fd divided by summation f. Here a is 170 and summation fd is minus 780 and summation f is 32. And I find out the solution x bar equal to 170 minus 24.375, which is equal to 145.625. Step deviation method. In order to simplify the calculation, we divide the deviation by the width of class intervals, that is, calculate x minus a by c and then multiply c in the formula for getting the mean of the data. The formula to calculate the arithmetic mean is x bar equal to a plus summation fd by summation of f into c, where d equal to x minus a by c. Let's see the problem. Find the mean of the following distribution using step deviation method. So in this table we can see the class interval as well as frequency. Now let's see the solution. Let assume mean a equal to 28 and class width c equal to 8. In this table I have mentioned class interval, mid value, frequency, d and fd. By using these values we can find out the solution. Mean x bar equal to a plus summation fd by summation f into c. Here a equal to 28, summation fd equal to minus 22, summation f equal to 100 and c equal to 8. By substituting these values in this formula, we can find out the value of mean x bar equal to 26.24. Let's see the properties of the arithmetic mean. The sum of the deviations of the entries from the arithmetic mean is always 0. If x1, x2, x3, etc. up to xn are n observations taken from the arithmetic mean x bar, then x1 minus x bar plus x2 minus x bar plus x3 minus x bar plus etc. up to xn minus x bar equal to 0. Hence, summation xi minus x bar where I varies from 1 to n equal to 0. Second property is, if each observation is increased or decreased by k, then the arithmetic mean is also increased or decreased by k respectively. Third property is, if each observation is multiplied or divided by k, where k not equal to 0, then the arithmetic mean is also multiplied or divided by the same quantity k respectively. Finally, let's see one problem. The average mark of 25 students was found to be 78.4. Later on, it was found that score of 96 was misread as 69. Find the correct mean of the marks. Given that total number of students n equal to 25. Here mean x bar equal to 78.4 and incorrect summation of x equal to x bar into n, which is equal to 78.4 into 25 equal to 1960. Correct summation of x equal to incorrect summation of x minus wrong entry plus correct entry. Then 1960 minus 69 plus 96 equal to 1987. Hence, correct x bar equal to correct summation of x divided by n, which is equal to 1987 by 25 equal to 79.48. Thank you.